Okay. Hi everyone. So first let me know, is audio and video, is it clear here? Audio and video, is it clear? Yes or no here? Is audio and video clear? Hi everyone. So let me know whether audio and video is clear. Is it clear here? Audio, video? Okay. 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 So good afternoon here. Good afternoon to all. So in the previous session, we have started rectangular coordinate system. In the previous session, we have started rectangular coordinate system here. Okay. So we have seen what are the differential lengths and what is a differential area and how to get a differential volume. All these things we have seen in the previous session. Understood? See, if you want to understand this subject clearly, you have to follow each and every lecture here in order. Okay. So then only you can easily understand the subject. Understood? Okay. So daily my lecture will start at this time only. Daily it will be 4 p.m. here. Daily it is going to start from 4 p.m. Understood? Okay. So it will continue for next to 25 days, 25 to 30 days maybe. Understood? Okay. So daily it will start at 4 p.m. daily at the same time. Understood? Okay. Yeah. So yesterday we have started a rectangular coordinate system and we have completed that rectangular coordinate system. Understood? So today we are going to start a cylindrical coordinate system here. Today we are going to start cylindrical coordinate system. Okay. Okay. Yeah. Okay. So we will start cylindrical coordinate system. So in cylindrical coordinate system, the coordinates are nothing but rho, phi and z. Rho, phi and z. Okay. Okay. Yeah. Rho, phi and z. Okay. So now first of all, if you understand how to construct a cylinder here. First of all, if you understand how to construct a cylinder, then it is very easy for us to visualize and analyze and understand this cylindrical coordinate system here. Okay. So first of all, we have to understand how to construct a cylinder. Okay. So now I am going to tell you the two ways to construct a cylinder. So the first one is, see here. Now here I am considering an axis here. I am considering an axis. Wait here. So here I am considering an axis here. I am considering an axis. Understood? Okay. Okay. So I am considering an axis. Now here from this axis, okay. So from this axis I am considering a point here. From this axis I am considering a point. P. Let us say this point is P. Understood? Okay. So let us assume this point, I am considering a point P which is at a normal distance here, which is at a normal distance rho here, So what I am considering here? I am considering a point P. I am considering a point P which is at a normal distance, rho, from the from this axis here. So this axis I am naming it as z axis. This axis I am considering it as z axis. So what I have done, I have taken z axis here, understood. So from the z axis I have considered a point, I have considered a point P which is at a normal distance, rho from the z axis, okay. So now my question is, what is the locus of all the points here? What is the locus of all the points which are at the same normal distance rho, from the z axis, So that means if you try to join all the points, surrounding this z axis which are at the same normal distance rho, then what is the shape you are going to get here? See, this is z axis here, okay. So let us consider a point which is at a normal distance rho from the z axis. So such type of points, if you join all such type of points surrounding the z axis, then what is the shape you are going to get? If you try to join all the points surrounding the z axis which are at the same normal distance rho, then what is the shape you are going to get here? Tell me, what is the shape you are going to get? Tell me here. What is the shape you are going to get? Tell me. Surya Prakash, good afternoon here, okay. Tell me, what is the shape you are going to get? If you try to join all the points which are at the same normal distance rho, surrounding the z axis, then what is the shape you are going to get? Tell me here. It is nothing but what? Very good here, very good, super. It is nothing but the curved surface of the cylinder or not? Yes or no? You are going to get the curved surface of the cylinder. Okay, now see here. So how we are going to get that? See here. So now if I try to join all the points here, so I am joining all the points which are at the same normal distance rho here. I am trying to join all the points which are at the same normal distance rho from the z axis. So if I join all these points, what I am going to get here? I am going to get a straight line like this. So all the points on this line here, are at the same normal distance rho, Understood? Okay. So now what I am going to do here is, if I rotate this line here, about this z axis, understood? If I rotate this line about this z axis, then what I am going to get? See, whenever you are rotating this line about this z axis here, what happens here? All the points on this line, are going to trace the circular paths or not? Yes or no? See, if you consider this point, whenever you are rotating this line about this z axis, this point is going to trace this circular path. Yes or no here? So what is the radius of this circular path here? The radius of this circular path will be rho. Understood? Similarly, this point will also, the point that is present here will also is going to trace the circular path. Similarly, this point will also trace the circular path. Similarly, the point here also going to trace the circular path. So all the points on this line are going to trace the circular path. So if you join all those points, you are going to get this shape. Yes or no here? You are going to get this shape. You are going to get this shape. Yes or no? Okay. Okay. Okay, so you are going to get this shape. So what is this shape here? This shape is nothing but what? The curved surface of the cylinder. Yes or no? It is nothing but the curved surface area of the cylinder. So how you are getting this curved surface area of the cylinder here? It is nothing but the locus of all the points surrounding the z axis which are at the same normal distance rho. Understood? If you join all those points, you are going to get this curved surface area of the cylinder. So note down that point here. Note down that point. So how you are getting? So I can say this curved surface of the cylinder is nothing but what here? It is nothing but the locus of all the points, surrounding z-axis, which are at the same normal distance, rho from the z-axis, Understood? Okay. So this is one way to construct the cylinder. Yes or no? Okay. Is it clear here? This is one way to construct the cylinder. So what is the another way here? To construct the cylinder here? So I will tell very simple method to construct the cylinder here. Okay. See, if I give you circular rings here, if I give you some 100 circular rings, all are of same radius, and ask you to construct a cylinder, then what you are going to do here? How you are going to construct? I have given to you some 100 circular rings, all are of same radius, and ask you to construct a cylinder. Then what you will do here? You are going to place one circular ring, above that another circular ring, above that another circular ring. You are going to place such type of circular rings one upon the other continuously up to some height h or not? Yes or no? So this is going to form the curved surface of the cylinder. So this is another way to construct the cylinder. Now if I ask you, what is the curved surface area? Of the cylinder? If I ask you what is the curved surface area of the cylinder, then how you can determine here? See, you have constructed the cylinder by placing all the circular rings one upon the other up to some height h. Yes or no? Now each circular ring is having the perimeter, is going to have the perimeter 2 pi rho. Yes or no? Let us assume each circular ring radius is rho. Then each circular ring is going to have the perimeter how much here? 2 pi rho. So now you have placed such type of circular rings. One upon the other up to some height h. Yes or no? So that means what is the curved surface area of the cylinder here? So each circular ring is having 2 pi rho. So like that you have placed such type of circular rings up to height h. So that means 2 pi rho times h. Will give you what? Will give you the curved surface area of the cylinder. Yes or no here? Okay. So this is how you have to visualize here. Understood? Now if I ask you what is the volume of the cylinder here? If I ask you what is the volume of the cylinder? Okay, so then how to tell the volume of the cylinder here? Tell me. Now instead of circular rings here, now consider circular discs here. Like this. Understood? Instead of circular rings, now consider circular discs here. Okay, so now if you place such type of circular rings, such type of circular discs, okay, one upon the other continuously up to some height h. Understood? So each circular disc is having the surface area of how much here? So let us say the radius is rho. Each circular disc is going to have the surface area of pi rho square. So such type of circular discs, you have placed one upon the other continuously up to some height h. Understood? So each is having pi rho square. Such type of circular discs you have placed one upon the other up to some height h. So what is the volume of the cylinder? Pi rho square times h. Yes or no? Pi rho square times h. So the volume of the cylinder is what here? Volume of cylinder is how much here? Is how much? pi rho square h. So here there is no need to remember any formulas and all. Yes or no? You can easily, if you understand how to construct a cylinder, you can easily tell the volume of the cylinder without remembering any formulas and all. Okay. Now what is the curved surface area of the cylinder here? Curved surface area. Curved surface area. Curved surface area of cylinder. So what we got? So you have to place circular rings. You have to place circular rings one upon the other up to some height h. Up to some height h. Yes or no? Okay. So each of radius rho. So each is having the perimeter 2 pi rho, and you have placed such type of circular rings up to some height h, and hence the curved surface area of the cylinder is how much here? Is nothing but 2 pi rho times h. 2 pi rho times h. Understood? Okay. So this is how you can easily visualize the cylinder here. Okay. Okay, yeah, fine. So I hope it is clear here. Okay. Okay. So now okay, so here I am drawing the cylinder here. This is z axis. Okay, wait. Okay. So this is the circular rings. How we have constructed? We have placed the circular rings one upon the other up to some height h. Okay. Okay. So this is how we have constructed the cylinder. We have placed circular rings one upon the other. Now see here. Now if you join the centers of all the circular rings here, if you join the centers of all the circular rings, you are going to get a straight line or not? Yes or no? So the locus of centers of all the circular rings is nothing but a straight line. Yes or no? Okay. Okay, fine. So now I am drawing a line. Okay, so this line is nothing but what? This line is nothing but I am joining all the centers of the circular rings. So if I join all the centers of the circular rings, I am going to get one straight line here. I am going to get one straight line. So this I am calling it as z axis here. This I am calling it as what here? Z axis. Understood? Okay. Now here I am considering this as x axis here. X axis, and here I am considering this axis as y axis. Understood? Okay. So how we got this z axis here? By joining the centers of all the circular rings, we got this z axis. So this z axis we call it as axis of the cylinder here. We call it as axis of the cylinder. Axis of the cylinder is nothing but the locus of all the points, the locus of the centers of all the points of the circular ring. Understood? Sorry. Axis of the cylinder means what here? Axis of the cylinder is nothing but it is the line that you are going to get by joining the centers of all the circular rings. That is nothing but axis of the cylinder. Understood? Okay. Now in general we will say cylinder is symmetric. Cylinder is symmetric with respect to its axis. What we will say here? In general we will say the cylinder is symmetric. The cylinder is symmetric with respect to its axis. Symmetric with respect to its axis. Okay. So we will say this statement here. What do you mean by this statement here? Cylinder is symmetric with respect to axis. What do you mean by that? Tell me. What do you mean by that? See here. Now if you consider okay, cylinder is symmetric with respect to its axis here. So what do you mean by that statement? See here, if you consider, what do you mean by symmetric? What do you mean by symmetric? This is what we are going to see first. Okay. Now, if I consider a point here, if I consider a point on the surface of the cylinder, okay, we know that this point is at a normal distance. This point is at a normal distance rho. Understood? Okay. So now I can find the same point here. I can find the similar point on the other side of the cylinder. Yes or no? Exactly 180 degrees to this. Okay, exactly opposite to this, I can find the same similar point on the surface of the cylinder, which is at the same normal distance, yes or no, which is at the same normal distance rho from this axis, yes or no. So this point here, I have considered one point here. Okay, so I can find out the same similar point on the other side of the cylinder, exactly opposite to this one, at the same normal distance rho from this axis. Understood? So these 2 points here, these 2 points, we call them as symmetric points here. We call them as what here? Symmetric points. Understood? Now similarly, if you consider a point here, let us assume you have considered a point here. Understood? So this point is also at the same normal distance rho. Yes or no? This point is also at the normal distance rho from the z-axis, Now for this point also, exactly opposite to this here, exactly opposite to this, that means exactly 180 degrees to this. Okay, I can find the similar point, which is at the same normal distance rho, So now these 2 points, I can call them as what? I can call them as symmetric points here. Okay, so these points are symmetric. With respect to what? With respect to the z-axis or not? Yes or no here? So these are called as symmetric points with respect to what? With respect to z-axis. Here z-axis is nothing but axis of the cylinder. Yes or no? Axis of the cylinder. Understood? So symmetric points with respect to what? With respect to axis of the cylinder. So that means all the points here, whatever the points you can consider on the surface of the cylinder, okay, so all the points are symmetric, with respect to the axis of the cylinder, and hence we call cylinder is symmetric with respect to its axis, Okay, so have you understood here what do you mean by symmetry? Yes or no? Tell me here, respond here. Arjit Acharya, thank you here. Thank you for your comment. Thank you. Okay. Have you understood here this one? Clear? What do you mean by symmetry? Yes or no? Yes or no here? Okay. So a cylinder is symmetric with respect to its axis. What do you mean by symmetric here? For each and every point on the surface of the cylinder, you can find out its symmetric point with respect to this axis here. So that's why we call cylinder is symmetric with respect to its axis. Understood? Okay. 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 Rahul. Okay, I will explain it again. Listen. See, if I consider one point here, if I consider a point on the surface of the cylinder, I can find the same similar point exactly opposite to this one on the other side of the cylinder. Yes or no? Exactly 180 degrees to this, I can find out the same other point. Yes or no? Which is at the same normal distance rho. With respect to this axis. That means I can say these 2 points are symmetric with respect to what? With respect to this z-axis. Now, if you consider this point here, if you consider a point here which is at a normal distance rho, from the z-axis. axis. So for this point you can find the same similar point on the opposite side, on the other side, exactly at 180 degrees. Yes or no? You can find the same similar point which is at the same normal distance rho from the z axis here. So we call these 2 points, we call these 2 points as what here? Symmetric with respect to what? With respect to this z axis, with respect to this z axis. So in that manner, for each and every point here, for each and every point on the surface of the cylinder, all those points are symmetric, all those points are symmetric with respect to what? With respect to this z axis. Understood? So that's why we call this cylinder as symmetric with respect to its axis, with respect to its axis. Okay, so I hope it is clear here. I hope it is clear. Okay, so I hope it is clear here. So symmetric points, okay, so I will give that point here. Okay, so all the points, note down this point here, all the points on the surface of the cylinder are symmetric with respect to, are symmetric with respect to axis of the cylinder, are symmetric with respect to axis of the cylinder. See, this condition will not be satisfied here. This condition will not be satisfied if you consider any other line here, any other line that is parallel to z axis. Suppose if I consider this line here, if I consider a line like this, okay, so then I cannot say the cylinder is symmetric with respect to this line. Yes or no? Yes or no here? See, the normal distance from this line to this point is different, and the normal distance from this line to this point is different. Understood? So you cannot find the symmetric points with respect to this line. If you consider another line like this, so with respect to this line also you cannot find out the symmetric points. So you can find out the symmetric points only with respect to this axis of the cylinder, and hence we call the cylinder is symmetric with respect to its axis. Understood? Okay, so I hope it is very clear here, crystal clear. Yes or no? Okay, okay, fine. Okay, fine. So next, here. Okay, so we have understood what is a cylinder, how it looks like, how to construct a cylinder. Okay, cylinder is symmetric with respect to its axis. What do you mean by symmetry? All these things we have studied. Okay, so now we will see these coordinates here, rho, phi, z. So what do you mean by rho? What do you mean by phi? What do you mean by z? So all these things we will see in detail. Okay, okay, yeah. So now here. Okay, so this is z axis, and we call this z axis as axis of the cylinder, okay. Okay, so this is x axis and this is y axis, okay. Okay, yeah. So now first we will see what do you mean by rho, okay. So first rho here, rho. So first write down the definition here, I will explain each and everything, okay. So rho is called radius of the cylinder here. Rho is called as what? Rho is called as radius of the cylinder. Okay, how it is defined here? It is defined as the normal distance the normal distance from the axis of the cylinder, to any point on the surface of the cylinder, okay. So rho is called as what here? Rho is called as the radius of the cylinder, and how it is defined here? It is defined as the normal distance from the axis of the cylinder to any point on the surface of the cylinder, okay. So that means, see here, now this is the axis of the cylinder here. So if I consider this point, okay, so the normal distance from the axis of the cylinder to this point is nothing but rho. Understood? So the normal distance from the axis of the cylinder to any point on the surface of the cylinder is nothing but rho. So this is also rho. So if I consider this point, the normal distance from the axis to this point is nothing but rho. So if I consider this point is also at a normal distance rho. So this point is also at a normal distance rho. This point is also at a normal distance rho. Understood? Okay. So here also I can draw the normal distance from the axis to any point on the surface. So this is also rho, this is also rho, this is also rho, this is also rho. Understood? Okay. So that means, so this point, if you consider this point is also at the normal distance rho. Understood? So what do you mean by rho here? Rho is the normal distance from the axis of the cylinder to any point on the surface of the cylinder, Understood? Okay. Okay, yeah. So now okay, that is nothing but rho here. So now what I can say here, you can easily you can simply remember this rho as what? See, the radius of each and every circular ring here. We have constructed the cylinder by placing the circular rings one upon the other. Yes or no? Now the radius of each and every circular ring is nothing but what? Is nothing but the radius of the cylinder or not? Yes or no? So you can easily visualize in this manner. Understood? So we have constructed a cylinder by placing the circular rings one upon the other. Okay, the radius of each circular ring is nothing but what? Is nothing but the radius of the cylinder. That is nothing but rho. Yes or no? Okay, it is simple or not? Yes or no here? Okay. Okay, yeah. Okay. So now as rho varies here, what happens to the size of the cylinder here? Tell me. That means we have to get the feel for rho now. Okay, we have to get the feel for rho. So what happens as rho varies? That means as rho changes here, the size of the cylinder is going to change or not? Yes or no here? So as rho goes on increases, the size of the cylinder is also going to increase. So as rho decreases, the size of the cylinder is also going to decrease. So rho will give you the feel for what? The feel for size of the cylinder. Yes or no? So as rho varies, the size of the cylinder is also going to vary. And now how you can vary the size here? You can vary the size from where to where? From where to where? You can vary the size from 0. Yes or no? You can make 0 cylinder and you can extend rho up to what? Up to what? You can make the size of the cylinder up to infinite. So that means what is the range of rho here? What is the range of rho? You can vary from 0 to what? 0 to infinity. Yes or no? So the range of rho is from 0 to infinity. So as rho varies, the size of the cylinder is going to vary, and you can vary the size of the cylinder from 0 to infinity. Yes or no? And hence the range of rho is from 0 to infinity. Understood? Okay. So I hope this point is clear here. I hope this point is clear. So you can write that point here. So as rho varies, size of the cylinder is going to vary. As rho varies, the size of the cylinder is going to vary. Okay, so you can vary the size of the cylinder from 0 to infinity, and hence range of rho is what here? It is going to vary from 0 to what? 0 to infinity. 0 to infinity. Understood? Okay. Okay. Yeah. Okay. Range of rho is from 0 to infinity. Understood? Okay. Fine. Now we will see what is the differential length. We will see what is the differential length along rho. What is the differential length along rho? Okay. See here. Now, if you consider here, if you consider a small differential length, if you consider a small differential length along rho here, if you consider a small differential length along rho, see, if you consider a small differential length along rho, okay, so as you move along this differential length, you are moving along a straight line path, or are you moving along a curved path? Tell me. As you move along this small differential length, okay, you are moving along a straight line path, or are you moving along a curved path? See, rho is nothing but what? Simply a straight line or not? So if you move along rho by a small differential length, yes or no? So you are going to move along a straight line path, yes or no? So and hence we can represent this small differential length, along rho, you can represent simply as what? You can represent simply as d rho. Understood? Yes or no? In rectangular coordinate systems, what we have done? We have considered a small differential length along x. Yes or no? That we have represented as simply dx ax cap. Now here we are considering a small differential length along rho. So that I can represent as what? That I can represent as simply d rho. And what is its direction here? Its direction is along what? Is along a rho cap. Its direction is along a rho cap. Yes or no? A rho cap represents the radial direction. Understood? And hence the differential length I can represent as d rho a rho cap. Understood? Now if I consider a small differential length at this location here, so then this will become what? This will become a rho cap. And this will become what? Here, this direction, radial direction is nothing but what? This is nothing but a rho cap. At this point, this represents a rho cap. At this point, this represents a rho cap. Understood? So a rho cap will always points in which direction here? Radial direction. Understood? So the differential length along rho, is nothing but simply d rho a rho cap. Understood? Okay. So differential length along rho here. So differential length along rho, is what here? Is nothing but simply d rho a rho cap. Okay, so this is the whole story. About rho. Understood? So rho is the normal distance from the axis of the cylinder. Rho is the normal distance from the axis of the cylinder to any point on the surface of the cylinder. As rho varies, the size of the cylinder is going to vary, and hence the range of rho is from 0 to infinity. And the small differential length along rho is nothing but d rho a rho cap. Okay, so is it clear here? Is it clear, guys? Tell me here, respond. Is it clear? Yes or no? Rahul, RS, Pavanishwar, Arjit Acharya, respond here. Is it clear? Okay. So I hope it is crystal clear here. Understood? Okay. Now, okay, so this is whole story of rho. So next we will see what do you mean by phi. Okay, phi. So first write down the definition here, then I will explain. Okay, so phi is the angle between x-axis and rho. Phi is the angle between x-axis and rho, and is measured or you can say Okay. So phi is the angle between x-axis and rho, and it is measured with respect to x-axis, and it is measured with respect to x-axis in anti-clockwise direction. It is measured with respect to x-axis in anti-clockwise direction. Okay, so this is the definition for phi r. Okay, these are not textbook definitions here. Okay, so these are our own definitions. Okay, so through which you can easily understand the concepts here. Okay, so phi is the angle between x-axis and rho, and it is measured with respect to x-axis in anti-clockwise direction. Okay, so now remember, see here. Now let us consider. Okay, so now let us consider a point here. Let us consider a point here. So let us assume a point here. Understood? Okay, so let us assume a point here. So now this point is at a normal distance rho. Yes or no? This point is at a normal distance rho from the z-axis. This is z-axis or not? Yes or no? So from the z-axis, this point is at a normal distance rho. So now I can represent this point here. I can represent this point as, this point is at normal distance rho from the z-axis. So this is rho. Understood? Okay, next, this point is lying in which plane here? It is lying in z equal to 0 plane or not? Yes or no? This is xy plane. Yes or no? This is nothing but xy plane. So this is the bottom. This circle is present in z equal to 0 plane, that is xy plane. So on this circle, this is nothing but what? This is nothing but z is equal to 0 plane. So that means all the points on this circle here, all the points on this circular ring, the z value will be what? Z value will be equal to 0. Yes or no? So z value will be equal to 0. Understood? Now I am considering another point here. I am considering another point, some point here. Okay, I am considering some point here. So now this point is also at the same normal distance rho. This point is also at the same normal distance rho from the z-axis. Now if I want to represent this point, I can represent it as, so it is at the normal distance rho, so I have to represent here coordinate rho. Understood? And this point is also on the z equal to 0 plane, and hence z value is also equal to what? Z value is also equal to 0. Understood? Now as I move from this point to this point here, let us say this point is P1, okay, this point is P2. Okay, so now as I move from P1 to P2 here, understood? Okay, that means see, listen here, wait. Okay, so now if you observe P1 and P2 here, P1 and P2, okay, so if you observe P1 and P2 here, okay, so here you are having rho comma 0, and here also this P2 is also having the coordinates rho comma 0. Understood? So you have to differentiate between these 2 points. Yes or no? These 2 points are not same. Yes or no? These 2 are different. So in order to differentiate between these 2 points here, we need one more coordinate. What is that coordinate here? See here, as you move from P1 to P2 here, okay, as you move from P1 to P2, you are moving along a straight line path, or are you moving along a curved path? Tell me, as you move from P1 to P2, you are moving along a straight line path, or you are moving along a curved path? Tell me here. As you move from P1 to P2, you are moving along a curved path or not? Yes or no? You are moving along the circumference of the circle from P1 to P2. That means you are tracing a curved path. Yes or no? So in order to represent the movement along the curved path, or in order to represent the movement along the circumference of the circle, you need what? You need an angle or not? Yes or no here? Okay, so in order to represent the movement along a curved path, or I can say the movement along the circumference of the circle, you need what? You need an angle. You need an angle. Yes or no? So that angle is nothing but what? That angle is nothing but phi. That angle is nothing but phi. So in order to measure phi here, in order to measure phi, you need some reference. You need some reference. So that reference axis is nothing but x-axis. That reference axis is nothing but x-axis. Yes or no? Okay. So the angle between x-axis and rho. So I am considering first this point here. So this point is at a normal distance rho. The angle between this x-axis and this rho is nothing but, let us say this is phi 1. So this angle is nothing but phi 1. So the angle between x-axis and rho in anti-clockwise direction is nothing but what? Is nothing but phi 1. So this phi is measured with respect to what? With reference to x-axis in anti-clockwise direction. Understood? Now this point, if I consider this point is also at the same normal distance rho. Understood? Okay, so this row is at an angle. This row is at an angle phi 2. This row is at an angle phi 2. Understood? Now I can represent this point as rho comma phi 1 comma 0, and this point as what? This point as rho comma phi 2 comma 0. Understood? Yes or no? Okay, so that means as you move from this point to this point, what is changing? Only phi value is changing. Understood? How you are going to measure this phi here? Phi is measured with respect to x-axis in anti-clockwise direction. Now we can differentiate between P1 and P2 or not? Yes or no? Okay, so now if you consider some other point here, so the normal distance from this axis to this point is nothing but rho, then you have to consider the angle. You have to consider the angle with respect to what? With respect to x-axis in anti-clockwise direction. This angle I can say phi 3. Understood? So like that, whatever the point you can consider here, for that point just consider a normal distance. You are going to get rho, then measure the angle between x-axis and rho. That is going to give you what? That is going to give you phi value. Understood? So that means what you can observe here, as this phi goes on increases here, then you are going to move along what? You are going to move along the circumference of the circle or not? Yes or no here? See, let us assume this is x-axis. Okay, so this is nothing but rho here. This is nothing but rho. So whenever rho and x-axis, both are in the same direction. Understood? When rho lies along x-axis, phi value will become what? Phi value will become 0. Yes or no? Okay, so now as rho moves away from x-axis, what happens here? Phi value gradually increases. So as phi increases here, you are going to move along what? You are going to move along the circumference of the circle. Yes or no? You are going to move along the circumference of the circle. Understood? Okay, so that means as phi varies, you are going to trace the circumference of the circle. You are going to move along the circumference of the circle. Yes or no? Okay, and hence what is the range of phi here? Range of phi is nothing but 0 to 2 pi. Yes or no? It completes one circle. Yes or no? Okay, so the range is from 0 to 2 pi. Understood? So note down that point here. So as phi varies, or you can say as phi increases here, so this arrow mark represents phi increases. So as phi increases, you are going to move along the circumference of the circle. You are going to move along the circumference of the circle. In which direction? In anti-clockwise direction. Yes or no? You are going to move along the circumference of the circle in anti-clockwise direction. Understood? And hence what is the range of phi here? Range of phi is nothing but what here? It is nothing but 0 to what? 0 to 2 pi. So whenever you are writing the range of phi here, you have to take care of these equalities. See, 0 and 2 pi will represent the same point or not? Yes or no here? 0 and 2 pi will represent the same point. So that means you should not include the same point twice. Okay, so that's why if you put equality here, don't include equality here, or if you put equality at 2 pi, then don't include equality here. Understood? So take care whenever you are writing the range of what? Range of phi. So it is from 0 to 2 pi. You should not, if you put equality here, you should not put equality here. If you put equality here, you should not put it here. Okay, because 0 and 2 pi will represent the same point. Understood? Okay, so now you have understood what do you mean by phi and what happens as phi varies. Understood? And what happens as phi varies. Understood? Okay, next point here. See here. Now okay, so now see here. Now I am considering this circle here. I am considering this circle. Okay, I am considering this circle that is present in z equal to 0 plane. So I am drawing that circle separately here. Okay. Okay, so I am drawing that circle separately here. So let us consider this is the circle. This is the circle. So I am drawing this circle here. Understood? So now here you are having x-axis and y-axis. So I am considering the x-axis in this direction. Okay, so this is x-axis and this is y-axis. Understood? So z-axis will come out of the board. Always you have to take care. Yes or no? If you curl your 4 fingers from x to y, the thumb is pointing out of the board. That means positive z-axis will come out of the board. So I am just considering this circle here. That's it. Understood? Okay. So now here I am considering a point. I am considering a point P1. I am considering a point P1. So this point P1 is at a normal distance. Is at a normal distance rho. Yes or no? This is at a normal distance rho. Okay, so now I am considering another point. I am considering another point, that is P2. So this P2 is also at a normal distance rho. This is also at a normal distance rho. Now let us consider the angle with respect to x-axis. The angle between x-axis and this rho, let us say this is phi 1. Okay, and the angle between this x-axis and this rho, let us say this is phi 2. Let us say this is phi 2. Understood? Then this angle is nothing but what? Phi 2 minus phi 1. This angle is nothing but phi 2 minus phi 1. So now let us assume phi 2 minus phi 1 is tending to 0. Phi 2 minus phi 1 is tending to 0. So that means I can write this difference as what here? I can simply write this difference as d phi. Yes or no here? So I am considering this phi 2 minus phi 1 is tending to 0. That means the difference between these two is very, very small. So I can consider it as simply d phi. So this angle is nothing but phi 2 minus phi 1. So this angle tending to 0. So that's why I am representing this with d phi. Understood? Okay. Okay. So this is nothing but d phi. Okay. So now see now we have seen how to determine the differential length along rho. Yes or no? Now we have to see how to determine the differential length along phi. See, whenever I am saying differential length along phi here, okay, see, whenever you are moving along phi here, so you are not moving along a straight line path. Yes or no? You are moving along a curved path. That means you have to consider what? You have to consider differential arc length along phi. Why here? Because as you vary phi, you are moving along what? You are moving along a curved path. Yes or no? You are not moving along a straight line path. You are moving along a curved path, and hence you have to consider what? You have to consider differential arc length. You have to consider differential arc length along phi. Understood? So now what is the differential arc length here? So this is nothing but what? This is nothing but the differential arc length. The differential arc length of this the differential arc length. Yes or no? So what is this differential arc length here? Tell me, what is this differential arc length? This is circle, its radius is rho, this angle is d phi. So this differential arc length is nothing but what? Is nothing but rho d phi. Yes or no? I hope you know this thing here. Yes or no? Okay, so rho d phi will give you the differential arc length. Yes or no? So now you have to determine the direction of this small differential arc. See, if you consider any small differential arc length here, then the direction of that arc, is given by the tangent drawn to that arc here. Okay, so now here we have considered a small differential arc. Now you can draw the tangent to this arc. You can draw the tangent to this arc in two ways. Yes or no? So one in anti-clockwise direction like this, or in clockwise direction like this. Yes or no? You can draw the tangent to this arc in two ways. One is in anti-clockwise direction like this, or another one is in clockwise direction like this. But which one you have to consider? Which one you have to consider? We are measuring phi in which direction? Anti-clockwise direction, and hence you have to consider the direction of this arc. You have to consider the direction of this arc in which direction? In anti-clockwise direction. So this direction we are naming it as what? A phi cap. A phi cap. So A phi cap represents the tangent drawn to the small differential arc in which direction? In anti-clockwise direction. Understood? So that means what is the differential arc length along phi here? What is the differential arc length along phi? That is nothing but what? Rho d phi A phi cap. Rho d phi A phi cap. Understood? Okay. Is it clear here? Is it clear? Tell me here. Respond. Okay. Is it clear here? Rho d phi A phi cap. So this is the differential arc length. This is the differential arc length along what? Along phi. Along phi. So now here this A phi is nothing but what? Is nothing but the tangent. Is nothing but the tangent drawn to the arc. It is nothing but the tangent drawn to the arc in which direction here? In anti-clockwise direction. In anti-clockwise direction. Understood? Okay. So is it clear here up till now? Up till now is it clear? Okay. Okay, yeah, fine. So tangent drawn to the arc in anti-clockwise direction. So now we have understood what do you mean by phi. We have understood what do you mean by phi. So phi is the angle between x-axis and rho, and it is measured with respect to x-axis in anti-clockwise direction. As phi varies, you are going to move along the circumference of the circle, and hence the range of phi is from 0 to 2 pi. Yes or no? As you are moving along phi, you are moving along the curved path, and hence you have to consider the differential arc length along phi, and the differential arc length along phi is nothing but rho d phi. So for the direction of differential arc length is always given by the tangent drawn to that arc. Okay, so here you have to draw the tangent in anti-clockwise direction, that is given by A phi cap. Understood? So rho d phi A phi cap is the differential arc length along phi. Understood? Okay, so I hope it is clear here. I hope it is clear. Okay. So rho completed, phi completed. Yes or no? Now what is remaining here? Z. I hope you can easily understand Z here. Yes or no? See, if I move from this point here, if I move from this point to this point here, if I move from this point to this point here, if I move from this point to this point, what is going to change? Tell me. As I move from this point to this point, so this point is also at the same normal distance. Yes or no? This point is also at the same normal distance rho. So that means this rho coordinate is not going to change. Understood? Okay. So now if you draw a parallel line, to x-axis, so now the angle between this line and rho, is same as what? Is same as this phi 1 or not? Yes or no? Is same as this phi 1. So this angle is nothing but phi 1. So this phi 1 is also not going to change. So as you move from this point to this point, rho is not going to change. Phi 1 is also not going to change. What is going to change? Z value is going to change. Yes or no? As you move from here to here, Z value is going to change. So let us assume this point on this line, let us assume this is 0, 0, Z1, 0, 0, Z1. Then this point will become what here? This point will become Z1. Understood? So as you move from this point to this point, what is changing? Rho value, phi value remains same. Z value is changing. Yes or no? Now if you increase this Z value here, if you increase this Z value, the height of the cylinder is going to increase or not? Yes or no here? If you go on increase this z value here, if you go on increase this z value in upward direction, then what happens? The height of the cylinder is going to increase or not? Yes or no? So that means z represents what here? As z varies, the height of the cylinder is going to change, Now you can increase the height of the cylinder either in upward direction, yes or no? Or you can increase the height of the cylinder in downward direction also or not? Yes or no? You can increase the height of the cylinder by extending the cylinder in downward direction or by extending the cylinder in upward direction. Understood? So that means what is the range of z here? What is the range of z? You can extend it up to plus infinity or you can extend it up to minus infinity. And as z varies, what is going to change here? What is going to change? The height of the cylinder is going to change. Understood? Okay. So that is all about z here. That is all about z. So z here. So z. See, the definition of z will remain same as in rectangular coordinate system here. Okay. But here in cylindrical coordinate system, as z varies, the height of the cylinder is going to vary. Yes or no? Okay. So as z varies, height of the cylinder will vary, and we can vary the height from minus infinity to plus infinity, and hence range of z is from where to where here? Is from minus infinity to what? Minus infinity to plus infinity. See, you cannot make exactly minus infinity or you cannot make exactly plus infinity. So you should not put equality here. Okay. Z is varying from minus infinity to plus infinity. So this is the range of z. Understood? Okay. Now, what is the differential length along z here? What is the differential length along z? See, as you move along z, you are moving along a straight line path or not? You are moving along a straight line path. So you can simply represent the differential length along z is simply nothing but what? Is nothing but dz az cap. Understood? Okay. So the differential length along z is nothing but dz az cap. So it is as simple as that. Okay. Now we have understood what is rho, what is phi, and what is z. Okay. Okay. So I hope it is clear here. I hope it is crystal clear here. What is rho, phi, and z? So this is the z axis here. Okay. So this is rho, the normal distance from the axis. So this is nothing but phi, yes or no? And if you move like this, this is nothing but z. Okay. So rho, phi, and z. So you are having the field for rho, that is represents size of the cylinder. You have the field for phi. If phi varies, you are going to move along the circumference of the circle, and also you are having the field for z. As z varies, the height of the cylinder is going to change. Understood? So it is as simple as that. And also we know the differential length along rho, the differential arc length along phi, and the differential length along z. Understood? Okay. So kadam here. Okay. So cylindrical coordinate system is completed. That means concept wise it is everything is completed. Understood? Okay. So now next see here. Okay. So one more thing I want to specify here is, now if I take a circular ring here, I am taking a circular ring that is, let us say, that is present in z equal to 0 plane here. I hope you remember this circle. Okay. So this is x axis and this is y axis. Yes or no? Okay. Now if I consider rho somewhere here, this is nothing but rho. Okay. So this is nothing but angle phi. Now see here, arrow cap direction is pointing in this direction or not? So this is nothing but arrow cap direction, that is radial direction. Now what is a phi cap direction here? A phi cap direction is given by what? Is given by tangent drawn to this arc in anti-clockwise direction. So this is nothing but what? This is nothing but a phi cap. Yes or no? Now we know that if you draw the we know that on a circle here, the radial direction and the tangential direction, both are what? Both are always perpendicular to one another. Yes or no? Yes or no here? This is orthogonal coordinate system or not? The direction of rho, the direction of phi must be what? Must be mutually perpendicular to one another. So the angle between these two, is nothing but what? Is nothing but 90 degrees. On a circle, always the radial direction and tangential direction are mutually perpendicular to one another. Understood? Now, if you draw the AZ cap here, Z direction is pointing in which direction? Out of the board or not? Yes or no? So Z axis is pointing out of the board. That means AZ cap is perpendicular to what? Is perpendicular to this plane. Yes or no? That means this AZ cap is perpendicular to both aero cap as well as what? A phi cap. So that means aero cap, A phi cap and AZ cap, three are mutually perpendicular to one another. Yes or no here? Okay. Is it clear here? Is it clear? Okay, yeah. Thank you, yeah. Thank you. So that's why we are calling it as what? Orthogonal coordinate system. Aero cap, A phi cap and AZ cap. Three are mutually perpendicular to one another. Okay. So now, see here. Now we will see how to represent the cylindrical coordinates, in terms of what? In terms of rectangular coordinates. How to represent the cylindrical coordinates in terms of rectangular coordinates. So what are the cylindrical coordinates we are having here? Rho, phi and z. Yes or no? So we are trying to represent what is rho and we are trying to represent rho in terms of rectangular coordinates and also phi in terms of rectangular coordinates, z in terms of what? In terms of rectangular coordinates. Understood? Okay. So now if you consider a cylinder here, I am drawing roughly. Okay. So I hope you can easily understand here. See here. Okay. Now see here. Now if I consider some point here, I am considering some point here. This is nothing but a rho. Okay. Now I want to represent this rho in terms of what? In terms of rectangular coordinates. So what I am doing here is, see this point is lying along z axis. So I am representing this point as 0, 0, z. Yes or no? 0, 0, z in rectangular coordinates. Now this point is lying somewhere in space like this or not? Okay, this point is lying somewhere in space like this. Understood? So that means in rectangular coordinate system, this point is going to have what? This point is going to have x coordinate, y coordinate and z coordinate. Yes or no? So I am representing this point in rectangular coordinates, that is x, y, z. It is lying somewhere in three-dimensional space, and this point is lying along z axis. That means this point I am representing as 0, 0, z. Now how we have defined rho here? Rho is nothing but what? The normal distance from the z axis to this point or not? Yes or no? That means the distance between these 2 points, is nothing but rho. Yes or no? Now what is the distance between these 2 points here? Tell me. So square root of x minus 0 whole square plus y minus 0 whole square plus z minus z whole square. Z minus z will become 0. Understood? So what you are going to get? Rho is equal to what? Rho is equal to square root of what? Square root of x square plus y square. Understood? So there is no need to remember anything here. Okay, everything we are analyzing, okay, and we are getting the result. So my main intention is to develop your analyzing capability, so that if you see anything new also, you can easily handle that. Okay. Yeah. So my intention is not to make you familiar with the mathematical formulas and procedures. Understood? So my intention is to develop your analyzing capability and your thought process and way of thinking. Understood? So that is going to help you whenever you get some new question in the examination also. Understood? Okay. So that is very important. Now see here. Now coming to phi. So how you can represent this phi in terms of rectangular coordinates. Now see here. So this is x-axis here. This is x-axis. This is nothing but y-axis. Okay. So this row I am considering this row between x and y. Okay, so I am considering a row between this x and y, some point here. So this is nothing but row. Understood? So I am drawing x-axis, y-axis. Between these two we are having rho. I am not drawing the circle here. Okay, just I am representing rho. Okay, so the angle between x-axis and rho is nothing but phi. Understood? So now this rho is neither along x nor along y. So that means it is going to have its components along x and along y. So what is the component of rho along x here? So the component of rho along x, what you have to do? Just to drop your normal from the head of rho onto this x-axis. So the distance from here to here, I am calling it as x component, that is x. And the distance from here to here, or if you drop your normal from this rho, from this head of the rho onto y-axis, the distance from here to here is nothing but y. So that means the distance from here to here is also nothing but what? Is also nothing but y. Understood? Now from this right angle triangle here, from this right angle triangle, from this right angle triangle. So how you can write x here? X is nothing but the component of rho along x-axis. That is equal to what? That is equal to, I can write it as what? Rho cos phi. Rho cos phi. We are very much familiar in determining the components. Yes or no? So in the first lecture itself I have explained. Okay. Next, y is equal to what? Y is equal to rho sin phi. Y is equal to rho sin phi. So we want to express phi in terms of what? In terms of rectangular coordinates. Rectangular coordinates. That means you have to eliminate here rho. You have to eliminate here rho. So for that, what we can do here? If you take the ratio y by x, if you take the ratio y by x, what you are going to get? Rho sin phi by rho cos phi. Rho will get cancelled. You will get what? You will get simply tan phi. You will get simply tan phi. So from here, phi is equal to what? Phi is equal to tan inverse of what? Tan inverse of y by x. Phi is equal to tan inverse of y by x. Understood? Okay. So here you can write phi is equal to what here? Phi is equal to tan inverse of what? Tan inverse of y by x. Y by x. And z is same as what? Z is same as z only. Understood? Okay. So there is no change in z. Z is same as z. The definition of z will remain same whether it is in rectangular coordinate system or cylindrical coordinate system. Okay, this is how you have to represent rho, phi and z in terms of what? In terms of rectangular coordinates. Similarly here, you can represent what here? You can represent the rectangular coordinates. You can represent the rectangular coordinates in terms of what? In terms of cylindrical coordinates. You can represent rectangular coordinates in terms of cylindrical coordinates. So how we can represent here? How we can represent? See here, the rectangular coordinates are nothing but x, y and z. The rectangular coordinates are nothing but x, y and z. So you want to represent this x, y, z in terms of cylindrical coordinates. See, already we have done that here. Yes or no? Already we have done that. See here, x is equal to what? X is equal to rho cos phi. Yes or no? Y is equal to what? Y is equal to rho sin phi. Z is same as what? Z is same as z. Understood? So there is no need to do anything again. So you can simply write x is equal to rho cos phi, y is equal to what? Y is equal to rho sin phi, and z will be same as what? Z will be same as z. So this is how you have to represent the rectangular coordinates. This is how you have to represent the rectangular coordinates in terms of what? In terms of cylindrical coordinates. Okay. So is it clear here? Is it clear up till now? Tell me here. Is it clear? RS, thank you here, thank you. Okay. Tell me here, up till now is it clear? Cylindrical coordinate system? Yes or no? Okay. 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 So here, so next we have to see the differential areas, how to form the differential areas, and how to form the differential volume, and also we have to see how to represent this aero cap, A phi cap, and all these things. Understood? Okay. So time will not be sufficient here today to complete all these things. Okay, so almost 70% of the cylindrical coordinate system is completed. Remaining only 30% is present here. So that we can cover in the next session, that is tomorrow here. So every day my class will be at 4 o'clock here. Okay, so 4 to 5 or 5 around 5. Okay, 5 or 5:30. Understood? So 4 to 5 or 5:30 daily it will be continued. So daily it will start at 4 o'clock here. Okay, so I hope it is very clear here up till now. So remaining part we are going to continue tomorrow here. Okay, so respond here. Okay, so I am winding up the session here. I am winding up the session right now, because the time is not sufficient to cover the remaining part of the cylindrical coordinate system. So that's why I am winding up the session. So we will continue this cylindrical coordinate system tomorrow at 4 p.m. exact this same timing. Okay, okay yaar. Thank you yaar. Thank you. Love you guys. Okay, bye yaar. Bye bye. Take care. Bye.